Prove the following identity where the angles involved are acute angles. There is nothing but less than 90 degree, for which the expressions are defined as this entire thing, this divided by this entire thing is equal to cosecant A plus cot A. Using the identity, so here they are given us a clue, right? We have to make use of this. So if you have to make use of this, my LHS need to have cosec and cot, which I don't have, right? So let's convert it. How? Well, we'll start with LHS cosec A minus sin A plus 1, this entire thing divided by cosec A plus sin A minus 1. So we'll divide by sin A throughout. That is, we are dividing both the numerator and denominator basically. So if I divide throughout, it will be balanced. Mathematically, it's balanced. Cos A by sin A minus sin A by sin A plus 1 by sin A, right? We divided the numerator terms and now the denominator terms. Cos A by sin A plus sin A by sin A minus 1 by sin A. So cos A by sin A is, we know that, cot A minus 1, right? Sin by sin is 1, so plus cosec A. Cot A plus 1 minus cosec A. Okay, now we have to jump to what they're given, the clue. So we express the LHS in terms of cot and cosec. That job is done. So let's make use of the identity. So we know that cosecant square A is equal to 1 plus cot square A. Now rearrange it. Cosecant square A minus cot square A is equal to 1. So this is in the form of A plus B into A minus B. Right? So this is equal to 1. So here we have minus 1. So I can substitute in place of that. I mean, that's the whole idea. That's why they're given all of this. So in trigonometry, wherever you get 1, try to substitute the identity. It will work out. That's the trick. For me, I prefer that because it's easier for you guys to do it. Once you get familiar, then things will change actually next year and all. You'll handle, if you have trigonometry, you'll handle it in a way different manner than what you're doing now. Anyways, so let me take the numerator and do it because it's a lot of, it will be a big expression. So we'll call this as equation A, right? So next is, first is your numerator, substituting A in numerator. So basically numerator is cot A minus, in place of 1, I'm writing this big expression. Okay, you know what, we will just rearrange it first. Minus of 1 so that you guys will understand. So this is equal to cot A plus cosec A minus cosec A plus, let me put this in brackets, plus brackets open, cot A brackets closed, into, we have cosec A minus cot A. So now cot A plus cosec A, cot A plus cosec A is common in both the terms. So if you want to understand where are the terms, so this is your first term and this into this is your second term. So we have cot A plus cosec A, that is common, and you are left out with 1 minus cosec A minus cot A, right? Okay, so we just did the math. Okay, we just did the math. So if you look at it, we want cot A plus cosec A, we got that. And this somehow we have to eliminate. Well, if you look at the denominator, it might be the same. So let me solve it a bit more. So this is cot A plus cosec A, right? Okay, I didn't write that well. Cosec A into 1 minus cosec A plus cot A, right? So we have, now we can do numerator by denominator. So numerator is cot A plus cosec A into 1 minus cosec A plus cot A, while the denominator turns out to be cot A plus 1 minus cosec A. Cot A plus 1 minus cosec A. So numerator and denominator, they have the same terms, is it not? We can cancel it. And thus we have the answer cot A plus cosec A. Okay, right? So have a look. First step was we converted everything to cosec and cot by dividing with sine, because cos A by sine A is cot A and 1 by sine A is cosec A, right? I hope you guys are familiar with this. If not, you won't understand this step. And after that, it's just a matter of using the identity. So in place of 1, you start substituting. In trigonometry, that's what you have to do. In place of 1, you start substituting and you got the answer. It's not that hard, right? Okay, so pause and have a look.